These are the angle bisector and angle addition notes. So first we're going to start with the angle addition postulate, and we've already talked about something similar. We did the segment addition postulate, and that's where we had a line segment and it was broken into two smaller line segments. And if we were to take the two smaller pieces and add them together, the sum of those would equal the length of the whole entire segment. So we're going to basically have the same type of work going on, except now we're going to use angles. So to kind of describe it in words, we have, all right, if point B is on the interior of angle RAD, so I want to go ahead and start drawing this. Remember, if there's no picture, it's always a really good idea to draw one. So if we have angle RAD, and remember when you name an angle, it's that center letter that you always want that letter to be your vertex of your angle. So they do have to go in the order RAD, so RAD. And we have point B is on the interior, so we're just going to put point B inside of the angle. Then the measure of angle RAD is equal to, all right, well, if point B is on the interior and we then can cut this angle into two different angles, then this whole entire angle RAD is equal to the sum of the measures of the two smaller angles. So this is where you just have to be careful and know how to name your angles. Again, you name angles using 3 letters. And the center letter does have to be the vertex of the angle. So again, the vertex is the point where the rays meet. So if we look, we have this angle on this side, and its name is from R to A to B. So RAB is one of the smaller angles, and the other small angle is on this side, and that is angle DAB. Now you could have also named it angle BAD. That's also a correct answer. So angles can be named. This one could be BAR and BAD, DAB, RAB. So either of those will work. So basically, if you take the two smaller angles, they're going to add together to equal the whole big angle. So now if we were to look at that just with symbols, we would say that the measure of angle RAD is equal to the measure of angle RAB plus the measure of angle DAB. The two pieces equal the whole thing. Again, something we've already talked about with segments. So now if we look at it with some numbers, with actual angle measurements, the question says find the measure of QRT. It's always a good idea to figure out what angle they're talking about. So I always like to highlight and go, okay, well, Q to R to T, they want this whole entire angle. Well, one small angle, QRS, is 15. And so we have a small angle QRS, and we have the other small angle as SRT. Well, together they should equal the whole entire angle. So we have one small angle is 15, the other one is 30. 30 plus 15 is 45, so the measure of angle QRT is 45 degrees. Now, with the algebra, again, you got to put on your hat of equation creator. You're going to, anytime you're asked to solve for x or find x, you need to make an equation that makes sense based off of the information given. Well, it is given to you that the measure of angle LKN, whole entire thing right there, is 145 degrees. So basically we have a whole big angle, and then you can see here that we also have the expressions for two smaller angles. So again, two pieces equal the whole thing. So we're going to take the two smaller angles. So here's the expressions for the two smaller angles. So the angle addition postulate says if you take the sum of the two smaller angles, that sum of the two small ones will always equal the sum of the bigger angle. So there's your equation you created based off of the angle addition postulate. Now again, first step in solving equations is always to combine like terms. So you're not moving left to right, right to left. You're just smushing everything together first. Combine these. Now we start, once everything's nice and condensed, then we start moving things to the other side of the equation. So we have to subtract 7 and subtract 7. So 6x is equal to 138. And then if we divide by 6, we get that x is equal to 23. There's your answer. So just a few more types of things to go along with angles. Congruent angles are two angles that have the same measure. So again, you got to kind of tie those words together. When we talk about the pieces, like the angles or the segments, we refer to them as being congruent. And remember, the symbol for congruent is the equal with a little tilde on top. Well, congruent pieces have equal measures. So if they have the same measure, then they are equal. So when we talk about names of certain pieces, we use congruent, and we talk about actual measurements like 45 degrees and 145 degrees. That's when we use equal. All right, we also have an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. And again, we've talked about something similar with the segment in that we have talked about a midpoint. A midpoint is something that divides an angle into two. Again, this word bisect, that prefix means two, and then this suffix here, sector, sections. So two equal sections. So again, to tie those words together, you want to say that congruent angles have equal measures. So now, if you look at that, well, let's look at the angle bisector with angle measures. So in the diagram at the right, WY bisects angle XYZ. So here's the big angle XYZ. And it's telling us that the measure of angle XYW is 18 degrees. So again, the important part when you do with angles is make sure you're putting the measurements in the correct angle on the diagram. So XYZ, again, XYW is 18 degrees. Now you'll notice here that we have these marks here. These are marks showing us that the two smaller angles are congruent to one another. So anytime you're given pieces are congruent, you'll see, or you may have to mark, the angles being congruent. So anytime you see the word bisect, that means it cuts it into two congruent pieces. So if you were drawing your own angle and you wanted to draw a ray that bisects into two small angles, you would need to then add the congruency marks. They're like little arches. Okay, so that means that those angles are congruent to one another. Now, if this one is 18 degrees, then if it's an angle bisector, cuts into two equal pieces, then that means this is 18 degrees. So to find the measure of the whole entire thing, we would add those together. So that is your measure of angle XYZ. Now with algebra, again, in the diagram, BD bisects angle ABC. So I'm going to go ahead and mark that. Anytime the picture is not marked, you want to go ahead and mark it. That's very important to do throughout geometry. So right away, we know that bisect means congruent pieces. So two congruent angles right away. And what we set up here, remember, if they're congruent, then they have equal measures because that tells you how to set up the equation. These pieces here are congruent. Well, congruent angles have equal measures. So we're going to take the two expressions and set them equal to each other. Because we know no matter what the expressions are, remember, expressions are just that. They're just a representation of an actual number that we can then find out what the actual measurement is. So if we subtract 3x from each side, 17 is equal to 4x minus 39. Add 39 to each side. So 56 is equal to 4x. So if we divide by 4, then our x is 14. So in geometry, it's always a good thing, always in all tests, is to go back and read the question. Well, our question said find the measure of angle ABC. So finding the measure of something and x are completely different. X is just a variable. This is representing how much something is changing. It's not a measurement. This is a measurement. So to get from one to the other, you have to take this x and you have to plug it back in to find the measure. So if we take that 14 and we plug it back in, and we really have to pay attention to what it's asking. It wants the measure of angle ABC. So that's the whole thing. Well, if we take this 14 and we plug it in to where the x is, 3 times 14 plus 17. And again, we only need to do this to one of these angles because they're both the same measure. And so then all we have to do is double it. So this comes out to 59. So since this angle is 59 degrees, we already know that that angle is 59 degrees because of the bisector. So that whole entire angle then is 118 degrees. Now, your turn. I would like you to do this problem. In the diagram, BD bisects angle ABC. Find the measure of angle ABC. All right, so what you do is 5x plus 16 is equal to 8x minus 23. Subtract 5 from both sides. 16 is equal to 3x minus 23. Add 23. So 39 is equal to 3x. If we divide 3 on each side, we get x is 13. But again, the question wants us to find the measure of the actual angle, so we have to take that 13 and plug it back in. So if we do 8 times 13, 8 times 13, and we subtract out 23, then you should get 81. Well, if that side of the angle is 81, this smaller angle is 81 again because you have the bisector. So if you add those together, 81 plus 81, you get 162 degrees for the measure of angle ABC. So one more couple of angles and a one angle pair. The last thing we need to talk about with the angles today are, these are called a linear pair. They are two adjacent. So remember, adjacent means right next to, touching. They're sharing a side. Two adjacent and supplementary. So again, remember, supplementary means 180 degrees. Actually, it means two angles that have a sum of 180 degrees. So we have right now that a linear pair are two adjacent and supplementary angles. In a linear pair, their non-common sides form opposite rays. And again, if you look at this word linear pair, you should see hidden inside that word linear is the word line. So that's where this whole thing, the idea of them being opposite rays, comes in. This picture here, so we have two angles. We have angle DAC and CAB. They're adjacent because, right, they're sharing this side, and they're supplementary because they are two angles who have a sum of 180. So remember again, the straight line, the straight angle is 180 degrees. These are their non-common sides. So these non-common sides form opposite rays because remember, opposite rays are two rays that have a common endpoint that extend forever in opposite directions. So there's our non-common sides forming an opposite ray, and then there's our common sides. So two angles that are adjacent that are also supplementary. So this is a linear pair, and these are not a linear pair. The reason these are not a linear pair, yes, are they two angles that are supplementary? Yes, because their sum are 180. However, they're not adjacent because you see they're not touching. So the only classification we could give to these two angles is that indeed they are supplementary because they're two angles whose sum is 180. Now let's look at it with angle measures. If the measure of angle 1 is 82 degrees, then find the measure of angle 2. Well, looking at this picture, you should know that this is a linear pair. We have two angles, and they're adjacent because they're sharing this side, and they form opposite rays. So that's a line. So we know when we add these two angles together that the sum is 180 degrees. So subtract 82 from each side. So if you take 180 minus 82, you should get 98. So that is the measure of angle 2. And again, check for reasonability. The measure of angle 2 is, obviously, if you look at the measure, or just look at angle 2, it's obtuse. So make sure your answer is something over 90 degrees, because if it's not, then it doesn't make sense. And you can always check your answer. Take your answer, add that back to 82, make sure you're getting back 180. Now again, with algebra, we always like to show it with the algebra. So solve for x. So here we go. We have two angles that are supplementary and they're adjacent. So I know that if I add those two together, they have to be supplementary. Combine your like terms. Divide by 6, divide by 6. X is 30. So again, you have basically two kind of general setups when you're dealing with solving for x and angles. We have the angle bisector. That's where they're congruent and you set things equal to each other. And this is our other case where we have linear pairs and the angles are supplementary, and that's where we're adding them together to 180. So here again, you try this one. So these guys, these are a linear pair. They're supplementary. So you should add these together and set them equal to 180. So try that out and put your answer into the video. Now, here's some other ones. Let's solve for x. So you're looking at C going, oh man, there's a X, there's a Y, there's a kind of a lot going on. So let's just kind of look at, all right, well, here is an angle that has an expression of X. It's here. And then we also have another angle that also has an expression for X. So really, we don't want to, the Y is something we don't need right now. So we're just going to solve for X. So you say, do I know anything about those angles that says that those angles are the same measure? No, they don't even look like the same measure because this purple one I have here is obtuse and this smaller one is acute. So I know like obtuse and acute are not the same size. And in math, when I say things are the same size, that means they're equal. So they're not equal, so my only other option is that they must be supplementary. So supplementary means that the sum of the two angles equals 180 degrees. So there I go again, setting up the equation, combining like terms. Divide each side by 34. So x is equal to 5. There we go. Look at D. D, we have to solve for y. So your two options again, you always want to run through. Do I know anything about the angles that tells me they're the same measure? Are they adjacent and supplementary? So if I look at here at y, these two angles here, and I always like to start with the one, are they equal to each other? So I always start with that one. Are they equal? Well, They both look like they're the same measure. I know that they're two angles that share just a vertex. Oh yeah, two angles that share a vertex are called vertical angles. Vertical angles are always congruent. So if angles are congruent, that means they have what? Oh yes, equal measures. Angles that are vertical have equal measures. So although the expressions are not equal, their measures will be. So if you set those equal to each other, so see, you're going to do the same thing throughout the majority of geometry. You're going to figure out if you need to add them together, if you need to set them equal to one another. So now we end up with 91, dividing that by 7, and we get 13. Now you could always check your work. You could take the 13 and plug it back in here. And if you did 2 times 13 plus 98, you get 124. Well, let's check to make sure we got the right answer. So if we go 9 times 13 plus 7, guess what we get? 124. We got the same measure for the angle, so we know that our variable is correct. All right, in E, again, a little bit of a review. I see here right away when I look at this, man, that right angle. So that helps me out a lot in geometry because that box right there on the vertex means that this side is 90-degree angle. It's a right angle. Well, a good thing about a right angle is if you have one side of a right angle, then this means that this side is also 90 degrees. So these are two 90-degree angles. What is that word again? I know I have supplementary. Oh yeah, complementary. So two angles whose sum is 90 degrees, those are called complementary angles. So, two angles whose sum is 90. See if I can turn that into math. Two angles whose sum is 90. Okay, I can do this. We can do this. Let's go. Two angles. There's one. Here's the other angle. It's two angles whose sum is 90. Because I know that if this side of the angle is 90, then these two smaller ones put together have to be equal to 90 because 90 is perpendicular. That means DB is straight. Combine like terms. Combine. Move things to the other side. 96 divided by 16, oh my gosh, we're almost done, is 6. There you go. Whose sum